Today I'll be finding all the roots of the polynomial 4x cubed plus 3x minus 2. Okay, so the simplest possible roots there could be for this polynomial would be rational numbers or integers. There's a quick test to attempt to find all the rational roots, if any, for a polynomial, and this is the rational root test. And the rational root test only works when the polynomial has integer coefficients. And we can see this polynomial has integer coefficients, so we can apply the rational root test. It says if x equals r divided by s is a rational root, where r and s are integers, and the greatest common divisor of r and s is equal to 1, which means the fractions in lowest terms. This is a rational root. We must have the following conditions. R must divide the constant term a0 of the polynomial. In this case, the constant term is is 2. So we have a0 equals 2. So r must divide, well, the constant term is minus 2, so r must divide minus 2. And the denominator s of the fraction must be a factor of the leading coefficient an. And in this case, the leading coefficient is 4. And this means s must be a factor of 4. So all the factors of negative 2, so this includes negative numbers and positive numbers, so r could equal plus minus 1 or plus minus 2. And s is a factor of 4, so s can equal plus minus 1 or plus minus 2 or plus minus 4. And if we look at these combinations, it turns out that all possible values of r over s, when you look at every single combination of plus minus 1, plus minus 2 divided by every single combination over here, all possible values of r over s are plus minus 1, plus minus 2, plus minus half, and plus minus 1 over 4. Okay, so we have 8 different possible values of the rational root. And now you could try testing all 8 of these values to see which of them actually is a rational root. Because these are potential values of a rational root, but it doesn't necessarily mean that they are a rational root. It turns out of these 8 values, the only value that is in fact a rational root is r over s is equal to half. And the reason for this is if we substitute x equal to half into the polynomial, we have 4x cubed plus 3x minus 2 is equal to 4 times half cubed plus 3 times half squared minus 2, and this is equal to half plus 3 over 4. Oh wait, this should say just x instead of x squared. So this will be half plus 3 over 2 minus 2. This equals 2 minus 2, which is equal to 0. This shows that x equals half is a rational root. And now, by the factor theorem, x minus half is a factor of the polynomial Okay, so this is because x equals half is a root, so using the factor theorem, x minus half is a factor. And to make it a little more convenient, I'll multiply x minus half by 2 to get 2x minus 1 is a factor of the polynomial as well. And now we can try to find the other factor of the original polynomial 4x cubed plus 3x minus 2 by doing polynomial long division. So we have our original polynomial and we long divided by 2x minus 1. So we'll have a 2x squared here, so there's a 4x cubed here, and there's a minus 2x squared. And what's left over is 2x squared plus 3x minus 2. And we have a x here, 2x squared minus x over here, and 4x minus 2. And finally we have a plus 2 here, 4x minus 2 here, and 0 remainder. This means we can factorize the original polynomial as 4x cubed plus 3x minus 2 is equal to 2x minus 1 times 2x squared plus x plus 2. Okay, to find the rest of the roots of this original polynomial, we already found x equals half from here. And now we have to solve this quadratic equation 2x squared plus x plus 2 equals 0. Using the quadratic formula, we get x is negative half plus minus the square root of 1 squared minus 4 times 2 times 2 divided by 2 times 2. Okay, and this is equal to negative 1 plus minus the square root of negative 15 divided by 4. This is negative 1 plus minus, so this is, since we are doing square root of negative 15, we have a non-real or complex root, which is I times the square root of 15 divided by 4. So these are the remaining two roots. So all three of the roots are x equals half and negative 1 plus I root 15 over 4 and negative 1 minus I root 15 over 4. These are all three of the roots. Okay, that finishes off the problem. So hope you enjoyed the video. Thanks for watching and I'll see you next time.